So now we have our next thing, that is rules of dimension. Okay, so what are the rules of dimension? That way you can identify that expression is correct or not, and how to identify other units, okay, on the formula. Okay, so what is, let's take first rule. Okay, in general we have a quantity, equation is there, P equal to Q plus RS. Okay, P have some dimension, Q have some dimension, and R have some dimension, and S have some dimension. Okay, if you are adding or subtracting some quantities, okay, and they are equal, if they are, so P equal to Q plus RS, and you are adding both of them, Q and RS. Okay, so what this rule says is that dimension of P is equals to dimension of Q is equals to dimension of RS. R into S, whatever dimension is making, that is equals to Q, and that is equals to P. Okay, so for adding and subtracting two quantities, their dimension should be equal, their dimension should be same. So like that you can't subtract velocity from acceleration, okay, because their dimensions are different. Okay, velocity can be subtracted from velocity only. Okay, understood? I hope you understand this. Like dimensionally I am checking. Okay, what is the formula, that is different thing. Okay, first priority is that dimensionally it should be correct, then we go for the next thing. Okay, next verification, that that formula is derived from where and then how. Okay, second rule, all trigonometric functions are dimensionless. So what I am saying here is sine, let's say one trigonometric ratio sine, and whatever written here, this is dimensionless. What is this? Dimensionless. Okay, and also this trigonometric ratio, this sine of, okay, this is also dimensionless. Okay, so with sine, like you have 4 sine theta. Okay, so 4 meter, let's see, 4 is a meter, and then you took sine component of that length. Okay, so 4 sine theta is gonna be your in meter only, because sine theta is basically dimensionless quantity, and whatever theta is inside, that is also dimensionless. Okay, so like that. Okay, next rule we have logarithmic. So for log, whatever log inside log you have the here, that is also dimensionless. Okay, how to use that we're gonna see some examples, we're gonna see, don't worry. Then we have e raised to power. Okay, whatever e raised to power we have here, okay, that is also dimensionless. Okay, so output of logarithmic and exponential function is also dimensionless. So output of this whole function is also dimensionless, this whole function is also dimensionless. Okay, that's all. Okay, I hope you understand. Now let's see how to use these things. Okay, now let's see one question. Alpha is equals to f into v divided by beta multiplied by sine beta t. Okay, this is the formula given. Then find dimension of alpha and beta. Here f is force, v is velocity, and t is time. Okay, so first of all, I know beta into t is dimensionless. Dimensionless means m0 L0 T0, right? And here it is beta into t to the power 1 m0 L0 T0, right? So here beta what came? T to the power 1 denominator, then above. So m0 L0 t to the power minus 1. Okay. Then we have here, this is sine of beta t is dimensionless, right? So this is only remaining, right? So I can write alpha, dimension of alpha. Okay, alpha is equals to f, force. What is the dimension of force? Okay, m1 L1 t to the power minus 2, right? And then velocity is L1 t to the power minus 1, right? Divided by beta. So beta we already calculated, right? So let's write down that m0 L0 t to the power minus 1. So what the dimension of alpha came? Alpha is equals to m1 L2 t to the power minus 2, right? You can cancel out the powers here, whatever. So m1 L square and t to the power minus 3 divided by minus 1, so minus 2. Okay, so this is your dimensions. Okay, dimension of alpha and beta. Now what is alpha and beta? That you don't have to worry about. Okay, so he asked the dimension, we calculated the dimension accordingly. Next question, one more question, let's see what is here. alpha by t square is equals to fv plus beta by x square. Here f is force, v is velocity, t is time, and x is distance. Okay, let's calculate this thing. Now first of all, if you are adding two things, fv and beta by x square, right? So this quantities should have dimensionally equal, right? So fv dimensionally it should be equal to beta by x square. Okay, dimensionally I am equating. So what is the force? Just now above we have seen the force, right? So what is that? m1 l1 t to the power minus 2, okay, multiply by velocity, that is l1 t to the power minus 1, right, divided by beta by x square. X square means l square, right? So beta came how much? Beta is m1 l square and l square, l raised to power 4 t to the power minus 3. Okay, so I hope this is clear. Now second thing which he asked is alpha. So here if you are equating these two things, so that should be equal, right? So dimensionally alpha by t square equals to f into v. So f into v is this only, right? m1 l1 t to the power minus 2 l1 t to the power minus 1, right? So alpha is equals to, if you take t square that side, okay, that is m1 l square t to the power minus 1. Okay, this is your alpha. So this is alpha and beta, we defined it. Okay, now let's see one more question. Okay, what is given here? Alpha is equals to fv square by beta square log of 2 pi beta by v. Okay, so we know inside log whatever quantity is there, that is dimensionless, right? Okay, so I know 2 pi beta divided by v is equals to m0 l0 t0, right? Now 2 pi is a constant value, so I can just eliminate that thing. Okay, just remove that thing, nothing, no use of that. Okay, this is just a constant. Okay, we are comparing the dimension quantities only. So beta divided by v, velocity is what? l1t minus 1, right? Okay, is equals to m0 l0 t0. So beta and this velocity have the same dimension. If you take this side, m0 l1 t to the power minus 1, right? So beta came. Now let's write down alpha. What is alpha? Alpha dimensionally log of 2 pi beta by v is dimensionless, so alpha dimension should be equal to f v square by beta square. So alpha is equals to f, force is what? m1 l 1 t to the power minus 2 multiply by v square, that is l1 t minus 1 square divided by beta square. So beta square means this square, that is l1 t minus 1 square, right? So here this whole quantity is getting cancelled out of this, right? And you get alpha as same as f only, right? m1 l1 t to the power minus 2. Okay, okay, I hope this is clear. Now see next thing we have use of dimension. Okay, how to use, really this is just dimension we are finding. We found dimensions of different quantities, okay, related to given in the formula. Okay, so we have, with the help of dimension we can write any physical quantity in terms of any other physical quantities. Okay, so this is kind of a point. On the basis of that we gonna write a question. So in a new system, force, velocity and time are the new fundamental quantities. Then write mass and work done in terms of these quantities. Okay, so this is our question. So what he is saying is that in new system we have a new system where force, velocity and time are fundamental quantities. Okay, so just like we are writing here m, l and t, there we write on whatever new system they write f, v and t as fundamental quantities, right? So this we're gonna see how to solve this question. Okay, first what he asked, he asked that you write mass and work done. So let's first write down mass, right? So mass we can write as f to the power, we don't know, so f to the power a, right? Power we don't know, and v to the power b and t to the power c. This is what, okay. Now let's just mass is mass to the power 1, right? And so just open it. It is simple, not that much hard, okay. Just open the bracket. Just whatever we write, force m1 l1 t to the power minus 2 to the power a, right? And velocity is l1 t to the power minus 1 to the power b, and time is just time only, right? So this to the power c. Now just take all the quantities together of mass, that is mass is 1 only, a. Then take L together, all the L together, that is this is a and this is b, a plus b, okay. And then we have time, this is minus 2a and this is minus b and this is plus c, okay. So if you compare here L is 0 and t is also 0, right, this side, right? So if you compare these quantities, okay, what can I write? A equal to 1 and a plus b equal to 0 and minus 2a minus b plus c equal to 0, right? So from these three equations if we write, then we get a equal to 1 and b equal to minus 1 and c equal to 1, okay. This is going to become, so I can write mass as, what can I write mass? Mass I can write f to the power 1 and v to the power minus 1 and t to the power 1 as it is, okay. Now next thing, work done. Let's solve for work done. So work done is force to the power a, velocity to the power b, time to the power c, right? Work done is what? Force into displacement, right? Force into displacement. So force into displacement, that is displacement, you can say displacement is what? L to the power 1, right? Equal to f to the power a, v to the power b and t to the power c, okay. So I hope this is you will able to do fast, right? Force to the power L. So okay, so from here I can directly, if we compare, so a came 1, okay, and what is remaining? L1 vb t to the power c, okay. So directly write down L1 and v is what? L1 t to the power minus 1 b t to the power c. So from here L1 and L to the power b and t to the power minus b plus c, right? So if you compare here, b equal to 1 and from then minus b plus c equal to 0, so c equal to also 1, okay. So what is work done formula came? For work done I can write f 1 and L also, v also 1 and t also 1, okay. This is my work done and this is my mass. This is how we write, okay. It can be asked in exam also, okay, possibly in test, unit test, and anywhere it can be asked. Then next thing is, write the help of dimension. We can almost derive any formula, okay. We can almost derive, we don't know exact formula, we can almost derive, okay. We can have a question on that, but it is not like always applicable, but it is almost everywhere we can write down this thing, okay. This is how we can solve, okay. So find dependency of time period of simple pendulum on length and acceleration due to gravity, okay. So first of all, this thing is given, what is given here? Acceleration due to gravity and length of the string, okay. So what we are saying is that time period is dependent upon length and gravity, okay. So something length to the power a and gravity to the power b, like that it is dependent, okay. So time period, so I can say time is proportional to length to the power a, and gravity is kind of acceleration, right? So acceleration I can write length to the power 1 t to the power minus 2, right, to the power b, okay. So here if you write t proportional to L to the power a plus b and t to the power minus 2b, okay. So if you compare here, okay, what is that? A plus b is gonna be 0 and minus 2b is gonna be your 1, okay. So from here b equal to, from these two equations I can write b equal to minus 1 by 2 and a equal to 1 by 2. Okay, so from here what we derived, t is proportional to length to the power, so L half and g to the power minus half. Okay, g to the power minus half. So I can say t is proportional to under root L by g. Okay, this is what we derived from here. Okay, now the exact formula which I tell you, exact formula, the actual formula which we have. Okay, the actual formula which we have is time period equals to 2 pi by under root L by g. This is the actual formula. So if you remove the proportionality constant, you're gonna get a constant, right? Some k, L by g. Okay, that constant actually is 2 pi. Okay, so that's how you almost derive the formula. You find out the dependency. Okay, it is dependent, it is like inversely dependent or directly dependent on that. Okay, like, so that's what you can at least find out the power, right? So you correct it. This is the one way, one use. Okay, let's go next topic. Okay, next topic is limitation of dimension. Okay, so in limitation what we see is here is, with the help of dimension we cannot have any information regarding the constant including in the formula. We can only find out dependency of quantity with any other physical quantity. So if you see here, we derived the formula, right? We derived the formula, but we don't have any relation about the constant. Okay, this is the limitation. You cannot find out the constant, what is the value of constant. Okay, by this you just find it out the dependency, right? So this is one like kind of, you can say, limitations. Okay, so what we have here, old system, that is m naught, L naught, you can say L naught and T naught, this I can say, right? And in new system I can say M, L and T, I am assuming that. Okay, so in given information, what is given, that M is 2 m naught. Okay, so new M is 2 times of m naught, and then L is 2 times of L naught, and T is 2 times of T naught. That's how it is given, right? And from the here I can write m naught is how much, m by 2, right? And L naught is how much, L by 2, and T naught is how much, T by 2, right? This I can write down. Sorry, here it is given as L naught by 2, right? So this is gonna be 2L. Okay, this is my 2L. Okay, I hope this till here it is clear, right? Now what is given in old system, this is 10 Newton. Just go by step by step. 10 is numerical value. Newton, what is the Newton formula? What we write for Newton? M0. So this is old, right? So M naught, right? M naught 1, L naught 1 and T naught minus 2, right? Okay. Now replace, we want to move from old to new, right? So we have to replace this old with the new. So m naught is equals to m by 2. Let's replace 10 into m naught is m by 2. Okay, to the power 1 only, right? So to the power 1, to the power 1. Okay, multiply by L naught to the power 1. So this is 2L. Okay, multiply by T naught to the power minus 2. That is T by 2 to the power minus 2. Okay, now if you solve this, you take all numerical values outside. Okay, so this is going to come 10 into 1 by 2 into 2 into 1 by 2 to the power minus 2 into new unit, right? So in new system, Newton. Okay, now if you calculate this value, this is going to come 40 Newton. Okay, in new system. In new system, this is the value. Okay, I hope this is clear. Okay, what we did, we moved from old system to the new system, same thing. Okay, so the remaining m m, l and t to the power minus 2, that is known as Newton, right? Okay, I hope this is clear. Now same thing we have gonna see with this joules. Okay, what is there? So 10 joules. Joule we know that is work done, so 10 m naught 1, this is for old system, m naught 1, so then you can say l naught to the power 2 t to d naught to the power minus 2. This is for joule, right? Okay, now if you write for the new, from the new system, okay, relation, this relation, if you write 10 m naught, that is m by 2 multiplied by l naught to the power 2, so 2l to the power 2, and t naught to the power minus 2, so t by 2 to the power minus 2. Okay, that's how. So this is gonna come 10 into 1 by 2 into 2 square into 1 by 2 to the power minus 2, right? And then m l square t to the power minus 2, right? And then this is gonna be how much? This is 80, and this is my joule, right? And in new system, okay, I hope this is clear, right? So this is how we convert from old system to new system. Okay, thank you.